Hello friends, today we are going to learn direct stiffness matrix. So we are going to solve 2023 spring question of direct stiffness matrix. A beam is given here. AB section there is UDL load and in BC section there is a point load of 15 kilonewton. So to solve direct stiffness matrix question, we can follow this rule deflection at A at this structure A and rotation is given. In B section there is, in B support there is deflection and rotation. Likewise in C section we can put a deflection and a rotation. So the equation to solve this direct stiffness matrix is this one. Deflection equals to K inverse P minus PL. We can either do this part or we can directly write K is equals to 12 EI by L cube, because this load is going upward. Likewise in AB coordinate, this rotation of is going anti-clockwise direction 6 EI L square. So we can keep that values and we can write this, and after this we can substitute the value from here. EI 3I, so EI is 2I. Likewise length in AB section 3 meter, in BC there is 1 meter and 2 meter. Likewise we can keep the values and we'll get this equation. For BC section we can again put this 12 EI by L cube and 6 EI by L square minus 12 EI by L square. We can memorize this formula and we can directly put this value, and in question it is given, so we can substitute this value in this equation and we can solve it. We'll get this value for KBC, and K is equals to KAB plus KBC. We'll get value of K. EI we can take common and we can solve this question for 6 into 6 matrix, this part, and this question, this part we can add and we'll get 1.33 plus 0.89, 1.33 plus 0.89, 2 plus 2 minus 1.33, likewise minus 2 minus 1.33, 4 and 2.67. This value we can just put and we can solve it. Then we'll get the equation is delay. Since there is fixed support in A, that's why deflection rotation both 0. In B there is roller support, in roller rotation only there will get no deflection. Likewise in C support and there is hinge, and in hinge we can get value of rotation but deflection will be 0. And in cohesion in beam there's no any extra force on deflection and moment, so E will be 0. And while solving this beam into two parts we can get value of moment minus 3.75, and deflection we can solve from here. Since it is UDL we can write WL by 2 formula and we can write this. In B there in this we'll get 7.5, in this we'll get 10, so we need to add it here. And in del B there will be formula for BA plus BC, and we can just solve it. So we'll get this value for PL. As I have told you earlier, in fixed, no rotation, no deflection. In ruler, no deflection, only rotation. Hence, no deflection, only rotation. This is just for note. And since in coordinate 1, 2, there is fixed support, so 0. In 3, deflection will be 0. In 5, there is in support, so deflection at C will be 0. Value of K will get this one for 2 into 2 matrix. Other all coordinate will just cancel out, and we'll get this one for 1, 2, 3, 5. There will be 0, and after solving this, we'll get the value for this one, except 1, 1, 2, 3, 5. We'll get this value for K. Now P is 0, PL for 4 and 6 will be this one, P minus PL. After solving, we'll get this K inverse. We'll just write inverse, and we are going to solve for theta B and theta C. Other will be 0. So we'll get value after solving in calculator 0.761 and minus 1.626. This much for today. Solve it by yourself and practice. Bye.